Hello everyone. So this is the second part of 5.5, solving polynomial equations. Yesterday, or in the previous lesson, we learned all the different types of factoring. Today we're going to have the same problems, but instead of all of them saying f of x equals this, that, or the other, all of them will say they equal 0. So what we're going to do is we're going to factor all of them. After factoring, you set each factor equal to 0 and solve. Now this could be very simple, could use basic algebra, but it might also use more advanced algebra like the square root method or the quadratic formula, which I have written here. So let's get to it. Factor and find all the roots. Find all the roots is just another way of saying solve the equation. The equation solutions are referred to occasionally as roots. So find all the roots means solve the equation. Okay, problem number 2. All the terms has a common factor of x. So I'm going to factor out x. I get x squared plus 7x plus 10. And then this is a trinomial, so I can do trinomial factoring. X and x, what multiplies to 10 and adds to 7, that's going to be plus 5 plus 2. This is equivalent to what we did in the previous lesson. Previous lesson, we'd stop here. In the new lesson now, we have to take each factor, and there are 3 of them, and set them all equal to 0. Once they're all set to 0, you solve them all. The first one already is solved. For the second one, you're going to have to subtract 5, and there's that solution. And on the third one, you're going to have to subtract 2, and that's that solution. So 0, -5, and -2 are 3 solutions to this equation. We check number 2 and make sure I'm right. And there, it gives the factor and the solutions. Let's look at number 4. Number 4, very similar to number 2. There's a common factor of x, so I'm going to factor out x. You get x squared minus 6x plus 9 equals 0. And then the resulting trinomial here can be factored, x. Two numbers that multiply to 9 and add up to -6, I believe, are going to be -3 and -3, right? They multiply to positive 9, but they add up to -6. Now this can also be written this way. Either of those could be good. I think the answer key is going to look like this, though. But now we need to solve it from here. So technically you're going to set each factor equal to 0. So x equals 0, x minus 3 equals 0. And then I'm going to take the other x minus 3 equal to 0 and solve that. I mean, I suppose you could. I mean, this one's already solved. For the second one, add 3 to both sides. But for the third one, you're just going to get this answer again. Now when that happens, sometimes that's called a multiplicity. So you might see an answer written like this. The answers are 0 and 3. You would never see the answer written like this, 0, 3, and 3, because you got the same answer a second time. That's really awkward, and it's just not something that's done in math. However, sometimes you'll see 0, 3, and then after the 3, you'll see multiplicity of 2, meaning that 3 is an answer twice. Multiplicity means it's happened more than once. So I expect the answer down below to look like this, and then maybe they'll use multiplicity. I honestly haven't looked ahead in this assignment. Okay, they abbreviate. So here's what it looks like factored. Then here's the 2 answers, 0 and 3, and then it states that 3 was an answer twice. It was the same answer twice in that problem. So multiplicity 2. And if you want to abbreviate, you don't have to write the whole word multiplicity out. That's fine. So there's number 2 and 4. Your 1 and 3 are going to be very much like those 2 problems. Let's look at number 6. Number 6 has 4 terms to it. 1, 2, 3, 4. That's a tip-off that you need to use the grouping method. Remember, that's where you split the equation in half, do common factoring from each half of the polynomial. So the first half has a common factor of x squared. If you divide that out, you get x minus 3. The second pair has a common factor of -3. If you divide that out, you get x minus 3. And then how do you finish grouping? You put down 2 sets of parentheses. The x minus 3 that matches goes in one set, and then the other numbers, x squared minus 3, goes in the other set. So now it's factored. It cannot be factored anymore, so you need to set each factor equal to 0. Right? And then solve them. The first one, when I solve it, I add 3 to both sides. I get x equals 3. There's one solution. For the second factor, I also add 3 to both sides. I get x squared equals 3. Now, the x is not isolated yet. Remember how to cancel out a square? You have to square root both sides. This was called the square root method. And then the other important note in the square root method is that you have to put a plus minus on your answer. Use the plus minus. So we get plus minus square root of 3. Now what is the square root of 3? It's not a rational number. It's not like square root of 9 or something easy like that. So we just call it the square root of 3. And those are our answers. So here's what it looks like factored. And those are the answers. Or I bet maybe the answer key is going to say 3, and then square root of 3, and then negative square root of 3. Probably write the answers separately like that. Maybe a plus sign here, maybe not for the plus minus. Let's check number 6. So here it is factored. 3 positive square root of 3, negative square root of 3. They just didn't write the plus sign for the plus minus. All right, that was kind of complicated. Number 8, very similar. Again, we have to use the grouping method. So here's our first group. Factor out x squared, you get x minus 2. From the second group, there really doesn't appear to be anything that we can factor. When that happens, remember you can always divide a 1 out of everything. And also, that's a plus, that's a minus. If we have to make it match here, I'm going to have to divide out a minus 1. So that gives me x minus 2. So now, when I break it down, the x minus 2 goes in one set of parentheses, and then x squared minus 1 goes in the other set of parentheses. But wait, there's more. X squared minus 1 is a difference of squares. We talked about this in the previous lesson. A difference of squares can break down into x plus 1 minus 1. So now this is completely factored. To find the roots or the solutions, you set each factor equal to 0 and then solve them. And it's pretty simple here. We're going to add 2, x equals 2, minus 1, x equals negative 1, plus 1, x equals positive 1. Or they'll probably write the answer 2, comma, negative 1, comma, positive 1. All right, let's check number 8 and see. Yep, there we go. Let's check out number 10. All right, so yeah, those were both grouping. Number 10 is not going to be grouping. I can tell because there's not 4 factors there, or 4 terms there. There's only 3 terms there. This was, from the previous lesson, if you remember, it was called the quadratic form. So we're still going to do trinomial factoring, but instead of putting x and x and then pick 2 numbers that multiply to 63 and add up to 16, you put x squared, and then 2 numbers that multiply to 63, add up to 16. So what's 63? Is that 7 times 9, right? 7 times 9 is 63, and if it's a negative 7 and a negative 9, it's negative 16. So we get this. Now, x squared minus 9 is a difference of squares. That is going to break down, factor, into x plus 3 minus 3. X squared minus 7 is not a difference of squares. 7's not a square number, so it's just going to stay like that. So this is what number 10 should look like when it is completely factored. Make that 0 look like a 0, not a 6. There we go. Now we need to solve it. So you set x squared minus 7 equal to 0, x plus 3 equals 0, x minus 3 equals 0. And then you got to solve each one of those. The last two are easy, so I'm going to do those first. You get x equals 3. Here, subtract x equals negative 3. Here, we're going to use the square root method again. So I got to add 7 to both sides. X squared equals 7. Now to isolate x, I have to square root both sides. And don't forget, when you square root, you put a plus minus on the answer. So I get negative 3, positive 3, negative square root of 7, positive square root of 7. So that's 2 answers, and there's 2 more answers for a total of 4 answers. All right, let's check number 10. And written in a little different order, but same answer. Number 12, probably going to work out real similar. So we'll go straight to trinomial factoring, only this is going to be x squared, x squared. We need 2 numbers that multiply to negative 2, add up to negative 1. Well, what is that? 2 times 1 is 2, negative 2 plus 1. There it is. Now, can any of these factor any further? No, none of them is a difference of squares. So this is it. This is factored. Set each factor equal to 0. And then solve them. We're going to use the square root method. So add 2 to both sides. X squared equals 2. Square root both sides. X equals plus or minus square root of 2. On the next one, subtract 1 on both sides. X squared equals negative 1. Square root both sides. X equals plus minus. Now, that looks sloppy as heck. Let me fix that. What's the square root of negative 1? Well, this is a whole lesson we had. The square root of negative 1, here I'll do note. Square root of negative 1 is what we called I. So this is going to be plus or minus I, the imaginary number. So our answers are square root of 2, negative square root of 2, I, and negative I. I hope I did it right. Let's check number 12. Yep, there it is. Goodness gracious. So we're digging up all sorts of things that we learned in the last marking period. Number 14. So this is a sum of cubes. X cubed, of course, is a cubed. Plus is a sum. 125 is 5 cubed. I gave you that chart yesterday, or the previous lesson. And if you recall the formula, a cubed plus b cubed equals a plus b, a squared minus ab plus b squared. So in this formula, when I factor this, everywhere there's an a, I'm going to put an x, and everywhere there's a b, I'm going to put a 5. I'll get those parentheses all set up. So it starts out with x plus 5. Then I go x squared. Then there's a minus sign. Then there's x times 5. And then there's a plus sign. And then plus b squared, I'm going to put 5 squared. Now if I clean this up a little bit, it's x squared minus, not x5, but 5x, and then plus 5 squared becomes plus 25 equals 0. I guess I left the equal 0 off there. So that's what it looks like factored. Now we have to set these factors equal to 0. Well, this is easy. X plus 5 equals 0, right? Doing this first one, that's no big deal. Minus 5, x equals negative 5. But what about this other factor here? If you remember yesterday, even though it's a trinomial, it does not break down any further into trinomial factoring. That's it. So how do we solve when we set this second factor equal to 0? Well, I feel like I'm breaking bad news to you. The way to do this part is with the quadratic formula. So if you don't remember the quadratic formula, it's negative b plus or minus the square root of b squared minus 4ac all over 2a. And in this problem, I'm going to change colors here a little bit. The A is 1, the B is -5, the C is positive 25. So to do this, it's going to be x equals -5, which of course, you know, two negatives make a positive, plus or minus the square root of -5 squared minus 4 times 1 times 25. Oops. All over 2 times 1. And then we need to simplify that, and boy, I'm not going to do this in my head. I'm too paranoid of making mistakes. So that part under the square root, remember that was called the discriminant. I don't know if you recall that, but I'm going to do this on the calculator all together. And is that right? Did I type everything in? -5 in parentheses squared minus 4 times 1 times 25. Yep, looks good. So this gives me -5, that's positive 5, plus or minus the square root of -75 all over 2 times 1, which is 2. Okay, boy, this is really getting bad because this kind of needs to be simplified, and I've run out of room. So the good thing about using the iPad like this is you can kind of circle this and squeeze it and make it smaller and give yourself more room. Of course, if you're using paper, you just use more paper, no big deal. All right, the square root of -75 can be simplified. There's a couple things going on there. So here's what I'm going to do. I'm going to do a little thought bubble off to the side here, where I'm going to examine the square root of -75. First of all, when you square root a negative, you're going to get an imaginary answer. So my answer is going to have I in it. It just has to. Secondly, 75 is not a square number, but it does break down into 3 times 25, and then 25 is 5 times 5, right? So I can do the square root of 3 times 5. We got a pair of 5s, that's 5 squared. And recall, what does a square root do to a square? It simplifies, so I can simplify out the 5, but the 3 is going to remain in the square root. Put that together with the fact that we have an imaginary number there, and we get 5i radical 3. So we get 5 plus or minus 5i radical 3 all over 2. And I realize that 3 doesn't look like English, so there. So what are my answers? The first answer was easy. That was -5. The second answer is 5 plus 5i radical 3 over 2. And the next answer is 5 minus 5i radical 3 over 2. And man, number 14, I sure hope I got this right. Yeah, probably would have lost all confidence in me if I made a mistake on that one. Yeah, that was pretty bad. And look, number 16, about the same way. So let's do this. Number 16 is a sum of cubes. The sum of cubes formula, a cubed plus b cubed equals a plus b, a squared minus ab plus b squared. 8, of course, is 2 to the third power. So everywhere there's an x, everywhere there's an a, that's where I'm going to put in x. And everywhere you see a b, that's where I'm going to plug in a 2. And wow, what was that? B squared parenthesis. Okay, so it's going to go x plus 2, x squared minus x2 plus 2 squared. And then that simplifies to x plus 2, x squared minus 2x plus 4. So there's the factoring part. The solving part, if I set the first factor equal to 0, that's easy street. You just get x equals -2, right? Subtract the 2 over, and there it is. For the next part, I got to use the quadratic formula. So that's -2 plus or minus the square root of -2 squared minus 4 times 1 times 4 all over 2 times 1. And I did leave out a step here. Hopefully it didn't confuse you. My A is 1, B is -2, C is 4. And of course, I'm just using the same formula from right here. All right, so if I simplify this, I'm going to do the discriminant part in the calculator, and it's real important that I put parentheses there. Without those parentheses, I will get the wrong answer. So -2 squared minus 4 times 1 times 4, -12. So x equals -2 is +2, plus or minus the square root of -12 all over 2. Now again, I've got the square root of a negative, so that means it's going to be imaginary. And also I have a 12 here, which is 3 times 4, and that's 2 times 2. And man, that -12. I didn't write that very well. So I've got a pair of 2's there, square root of 3 times 2 squared. I can simplify out the 2 radical 3, and again, because I was square rooting a negative, that means I do have to have an I in there. So this becomes 2 plus or minus 2I radical 3 all over 2. Now this answer is a little special because every term is divisible by 2. You can reduce this like any fraction, and you end up with 1 plus or minus 1I radical 3 over 1. So our final answer is going to be -2. It's going to be, this answer. And then 1 plus I radical 3, and then 1 minus I radical 3. You don't really have to write in this one or that one in your final answer. There it is. Holy smokes. So let's check number 16. -2, 1 plus I radical 3, 1I minus radical 3. Or 1 minus I radical 3, yeah. Okay, so this is a challenge. This is by far the most difficult thing I think we've ever done in this class. There is no quiz this week, so focus on your work, get it done, do your best, and by all means, contact me if you have trouble. I will do the Google Meets, I can do individual help or whatever it takes. Just let me know. Otherwise, I will